are some of the things you need to know for dynamics. Right? Definition for change in momentum, force, then the vectors. Remember, is the sum of momentum of body A and B before collision, I for initial, and then this is the sum of momentum after collision, F for final, A for body A, B for body B. This is a vector equation. Right? That means you have to draw a picture. We need to use vector triangle to find the resultant vector, or use component method, either one. Momentum is conserved, not velocity. Important that. Not velocity. Momentum is conserved. And the examiner doesn't like the word conserve, because it doesn't tell the examiner that you understand the word. So don't use the word conserve. Say moment in a collision, total momentum before collision equals to total momentum after collision. Right? So this one summarized for you. Two atoms collide, and then this is after collision. So you add the momentum of this one, that one, right? This one, that one, equals to momentum after collision. Doesn't matter which one comes first. This one and that is the resultant. Okay, let us solve the problem. A plug A, that's a plug A, sliding on a frictionless surface collide with a stationary plug B. So plug B, as shown in the figure. After collision, the plug move as shown. Okay. After collision, plug A move in 30 degrees to the initial direction. Plug B move 45 degrees to the original direction. Mass of plug A is given. Speed of plug A is given. Use the information to calculate the mass of plug B. This mass is not given, you're asked to find that. So the initial momentum is just 0.6 times U. 0.6 times U, there's the initial momentum of plug A. Plug B is stationary, so don't have momentum. So the final momentum of plug A equals to 0.4 or 0.6 and 0.4, right? In this direction, 30 degrees to the original direction. Right? And then there's the plug B. So let us just redraw that as a picture. Final momentum of plug B is mass M for mass of B times the speed of B. Okay. So we can start with either AF, what? Final momentum of body A, or final momentum of body B. Right? Up to us, any choice we want vector addition. So we start with body A, that's your body A, 0.24. So sum of momentum initially equals sum of momentum for finally. So PAI equals to PAF plus this is initial momentum. This is the final momentum for body A, body B. Remember, it's a vector equation. You have to draw the diagram. I draw this one first. Momentum of body A, is this one. And momentum of body B, which is 45 degrees to the this horizontal line, body B, 45 degrees, and then it's the resultant momentum, which is this one, 0.6 U, and then the unit. So 180 minus 30 minus 45 will give you 105. Okay. Initial momentum, 0.3 M. Right? We use sine rule. This one over that equals to this one over that. So sine 45. So 0.3 M cross multiply. 0.24 sine 45 and sine 30. Use your calculator to calculate out. Then you can calculate your M. Okay.
Okay.
Any comment?
No.
Okay. So that is by using vector addition. Can now work with velocity. Remember that. Students always confuse momentum with velocity. Cannot use velocity, but must use momentum. Because momentum is conserved, not velocity. Right? Work with momentum as momentum is conserved. Identify the resultant momentum. Right? The resultant momentum. Right? We can resolve it. We can resolve this vector into its component in the y direction and x direction. This one have non-vertical component in the resultant direction. So, same picture. We are using component PAI equals to PAF. That's a vector equation that we have written earlier. We're solving vertically. This horizontal, that one. Vertically is 30. So this is a momentum, 0.24 sine 30, which up there. And then this is 0.3 M down here. 0.3 M. And horizontally, we have 0.24 cos 30. Right? We're not interested in that. So we are interested in this one equals to this vector. 0.24 sine 30 equals 0.24 sine 45. And we can calculate our M. Okay. Any comment or anything here? Yeah.
Okay.
Right, let's try the second one. Right, if you use horizontal component, the same thing. Right? Is 0.24 cos 30, and then 0.3 M cos 45. So this one equals to this one plus that one there. And the same way, you can use the mass given there to find the speed of U. That speed. Right? Speed of body B after collision. Sorry, not the speed of the speed after collision is the speed, initial speed of body A before collision, which is not given. Okay. Okay, no comment.
Sure.
Okay, let's
Oh, teacher.
Yeah.
I have a question, right? So if it's upwards and downwards, can I still plus?
See
I mean
again.
like left and right. You see, right?
Here, it's very difficult to say upwards or downwards, unless the question is clear. So you can, if you draw the diagram, you can say upwards or y direction, downward y direction. These two must be equal. And then the one to the
Can
left
plus
equals to the total to the right. Okay. Anything else to ask?
But I can just plus lah.
Say again.
The direction doesn't matter, I can still plus.
Can't hear, can't hear.
I can just sum them up.
Yeah, because these are in the same direction. This is in the x direction, this in the x direction. So the two x direction add up must be equal to the initial one. Whereas this one is in the y direction. Y direction, they must be equal to give a resultant
Okay.
0. Okay,
Yeah.
let's try one more. The second one, partial paper. State the law of conservation of momentum. This one should be, this one is 206, June, paper 13. That's where he started and did this two-dimension syllabus. Conservation of momentum in two dimension. Total momentum of system of colliding particles remain constant provided there is no resultant external force acting on the system, or the one no resultant external force acting on the system can say isolated or closed system. Same thing. Okay, two particles A and B collide elastically. Key is elastically as illustrated in figure 5.1. There's initially B at rest. A moving at 500 meters per second. And then this is after collision. Initial momentum of A is 500 meters per second in the x direction, and B is at rest. The velocity of A after collision is VA at 60 degrees to the x direction, and velocity of B after collision is VB at 30 degrees to the x direction. Mass of each particle is given 1.67 times 10 to the power minus 27 kilogram. Understand the problem. Write down the quantities given. Mass is given. Mass is given. And then the speed is given. Write down on the paper itself. Then you can remember that. Okay. So all is given. Explain what is meant by particles colliding elastically. Okay. Can you tell me what is meant by particles colliding elastically?
Um, no no loss. I mean kinetic energy is conserved.
You must say kinetic energy before collision equals to kinetic energy after collision.
I cannot say conserve. Okay.
Right? Total kinetic energy before the collision equals to total kinetic energy after collision. Calculate the initial momentum of A and B. Calculate the total initial momentum of A and B. Right? This one's take you through step by step. Total momentum is mu, B is 0. Right? So mass, that is your mass. Times 500. Okay. Okay. State an expression in terms of m, VA, VB for total momentum of A and B after collision in the x direction. Right? So this one,
X direction. VA is
what is the value?
cos cos 60. V cos 60.
Yeah, two of them, MVA cos 60 and then MVB cos 30, add them together. Or what they did was the alternative answer lah. Then in the y direction would be they take upwards as positive, downwards as negative lor. So MVA sin 60 minus MVB sin 30.
Wait, teacher.
Yeah.
Oh, why they can use Pythagoras theorem?
Say again.
They use Pythagoras theorem to
Yeah,
find the
that's why they use
magnitude.
Pythagoras theorem. This one, no? This one, Pythagoras theorem. That's the alternative answer, no? That's the Pythagoras theorem,
Oh,
no?
alright.
Right? PA. That's your PA. This is 90 degrees. PB. PB 90 degrees. And PI we can calculate out. So you use Pythagoras theorem. That's why you get this answer. Okay.
Mm.
Calculate the magnitude of velocity VA and VB. Right? That's what we have calculated previously in the previous slide. Right? If you use this picture, cos 60 equals to adjacent over hypotenuse. Right? Any method you want to use to solve is up to you. Put in the value in, calculate out. VA is 250 meter per second. Okay. That's your PI. That's your mass. That's your VA. Okay. Yep. Any comment? Anything not clear?
Don't have.
Got it, okay. Right? Then you resolve the other component. No? Either you use this picture or use component method. Use the original that you have derived or use the Pythagoras theorem. Right? This one is sine further away. So it's PI sine 60 equals to MPB VB. So VB is 430. No? Okay or not? I've simplified the steps and show you the mass. Mass is given. Mass is given for B and A. Anything that is not clear? Yep. Anything that's not clear? It's up to you to choose in the exam which method you prefer to get you the simplest answer rather than complicated answer.
Yeah, can.
Okay,
Yep.
okay, let's just go to review our conservation of momentum. Okay, remember to memorize it. This is past year paper. I just review with you what we have learned last week, halfway. Right? Memorize. In all collision, momentum is conserved. Don't use the word conserve. Explain it. Examiner don't like it. They won't give you full mark. That is the total momentum before and after collision are equal. In elastic collision, an additional condition is kinetic energy must be conserved. That means kinetic energy before collision equals kinetic energy after collision, or relative velocity of approach equals relative velocity of separation. Right? So you either memorize this formula, this is all of them going together, and then after collision, they are moving, both of them moving apart. And then you must be able to write the conservation of momentum formula from this picture. And if it's elastic collision, then you should be able to write the equation for kinetic energy. Okay, any comment? Anything not clear? So it means that if it's this direction, is as positive. If it's opposite direction, it's negative. Same here, right? If this direction is positive, VA and VB, if it's opposite to this one, negative. Right? You can show it by this picture. Right? Depend on which one your teacher asks you to memorize. Right? This one, you can memorize it this way if you want to. UA always start first. Right? This one is in the wrong direction, so it's negative. Then separation is VB move faster than VA. So VB, right? This one should be in the opposite direction, it's going to be positive, but it's this direction, so it's negative. So you prefer to memorize it this way, go ahead. Okay,
Yeah.
any comment? No, let's try some
No.
question. Right, number 21. Yeah, well, I give you the answer. Try number 21. Why I give you the answer? Right, a stationary body explodes into two components, M and 2M. The component that gain kinetic energy are X and Y. X is
0. Stationary.
what is the value of, what is the answer? What is the value of X to Y? Yep.
Is this elastic?
No, no, explosion is never elastic. You start with momentum, conservation of momentum. Right? Start
Oh,
momentum
yeah.
initially, you start
0.
momentum finally. Right? Initial, no, nothing. Both of them stationary. So 0. And 2M, we take to the right as positive. So it's 2M times V. And then the other direction is M times V, negative. So M and N can cancel off. You get V equals to 2V. Then you have to
X. So it's 2, 1. C.
so you want X, kinetic energy of X, kinetic energy of Y, kinetic energy of X is half M V squared. Kinetic energy of Y is half 2M V squared. Half and half can cancel off. M and N can cancel off. Then you can replace your V with 2V. Right? V with 2V. So it's 2V squared. V and V can cancel off. So you still got This one is 2 square is 4. 4 divided by 2 is 2. So answer is 0. Can.
Yeah.
Try this one. Diagram shows two spherical masses approaching each other head-on at an equal speed u. One has a mass 2m, the other has a mass m. Which diagram shows the situation after collision? Which diagram showing the situation after collision shows the result of the elastic collision?
Wait, no, it's either D or C.
Not A, not B or C one. You must always be sure. Right? You can
I think it's D.
relative velocity is A or B only. Usually, they won't force you to try all of them. Right? For elastic collision, relative velocity of approach equals relative velocity of separation. So, relative velocity of approach, right? They are approaching each other. So we are using this formula. Approach. Okay. So we add them up. This is 2u. And relative velocity of separation, you can try for this one. Right? You can add them up also. 2u. So we can get our answer straight away. This one is after collision is let me just remove it. Right? Add them up, this one times together, these two times together, you get that one there, add them up. Right? Same with the others. You can see there. Answer is always A or B only. Can.
Yeah. The answer is D, right?
Answer is A. There.
Wait,
2u. Velocity, relative velocity of relative velocity of separation.
both of them moving at the same speed. How is M able to like push 2M?
You don't have to worry, you just look at the picture, that's all. Right? So likely is A because this is greater momentum, this is less momentum, so this is likely to move to the right.
Oh yeah, true. I mean,
You must use relative velocity of approach or relative velocity of separation. In this question, you are using this one, this formula. Depend on which one you memorize. Right? Or you use the other one, then it's the same thing. Okay. Okay, try this one. A bullet. Oh, you got 10 more minutes. A bullet of mass 2 gram is fired horizontally into a block of wood of mass 600 gram. The block is suspended from the string so that it is free to move in a vertical plane. They show you the picture. That's the initial position. That's after the bullet has gone in. The bullet buries in the block. Right? It doesn't pass through. It stays inside there. And the block and bullet rises together through a vertical distance of 8.6 cm as shown in the figure. I understand the problem. The bullet enters the block. Momentum is conserved. Both bullet and the block together move upwards with common velocity. Right? That is stationary initially. Bullet enter, both of them, bullet and the block move up to a height of 8.6. The block will move to a maximum height where all the kinetic energy of the bullet and block now becomes the potential energy of both. Right? Write down what is given as M, as U, as capital M, as block and bullet together. Calculate the change in gravitational potential energy of the bullet, of the block and bullet. Right?
Change in GVE.
Total mass, mgh, that's all. Show that the initial speed of the bullet and block, the initial speed of the block and the bullet after they began to move together, off together is 1.3 meter per second. Right? Conservation of energy, loss in kinetic equals gain in potential. So both of them move together. Right? That's the block, that's the bullet. Right? Change it to kilogram, sorry. And then that is potential energy that we have calculated. So from there we can calculate the speed. Okay?
The teacher.
Yeah.
This exact question came out in my exam.
Oh, this is an old question. June 2005. So no need to go
205.
2005 June. This is an old question. Using information in A part 2 and the principle of conservation of momentum, determine the speed of the bullet before impact with the block. Okay, so they have told you already what to do. Conservation of momentum, total momentum initially equal total momentum finally. Right? Initially, change it to kilogram times U. As the bullet and the block move together after collision. With that speed that we just calculated, then calculate our U. Calculate the kinetic energy of the bullet before impact. Okay. Okay with that? State and explain what can be deduced from the answer to C1 and A1 about the type of collision between the bullet and the block. Yep. That's A1. Right? Yep. C1 is here. Is it elastic or inelastic collision? That's all they are asking for. Since the kinetic energy of both before impact is greater than kinetic energy of the block and bullet after impact, the collision is inelastic. Okay.
Okay.
We will have to be stuck halfway lah.
Okay.
58. Define force. That one you should be able to define. Right? Since we are running out of time, I just write for you. Force is the rate of change in momentum. State Newton's third law of motion. Don't say action and reaction are equal and opposite. Push or pull of body A on B is equals to the push and pull of body B on A. Forces are the same kind.
Okay, I say for every action there's a opposite and equal
They
reaction.
don't like. They don't like that.
They don't like it.
Pull.
Okay.
Okay, two spheres approach one another along a line joining their centers as illustrated in figure 3.1. When they collide, the average force acting on sphere A is Fa, and average force acting on sphere B is Fb. The force act for time Ta for sphere A and time Tb for sphere B. You try forces after this, after the next 40 minutes you use for forces. Forces act on time TA for sphere A and time TB for sphere B. State the relationship FA plus third law. FA equals to minus FB and TA equals to TB. Use your answer in 1 to show the change in momentum of A and B is equal to magnitude and opposite in direction to the momentum of B. Change in momentum of B. Right? Just use that. We asked to define what is force. Right? Use that and write down force is change in momentum over time. So change in momentum is force times time. Right? FA times TA, FB times TB. Okay or not?
Yep.
I'm going fast because we are running out of time. For sphere B, the variation with time and momentum of sphere A before and during and after the collision with sphere B are shown in figure. Okay, that's sphere A, that's sphere B. Momentum of sphere B before collision is also shown in figure 3.2. Complete to show the variation with time of the momentum of B during and after the collision. Right, calculate out. Right, this is 6 minus 4. After collision is you are given this is minus 3 plus x. Momentum of B is 5. So that's the answer. Can
Yeah.
rate is the original direction. Sphere B is given. You just read the value, that's all. And
Yeah, I want to ask again.
say again.
I want to ask something. Loss in KE equals to gain in GPE, right?
Which topic are you talking about?
Momentum. Loss in KE equals to gain in
Are you
GPE.
discussing this question, is it?
No, the previous one.
Previous one, tell me previous one.
Oh yeah, it is. All right. See you.
There is a loss in potential kinetic energy equals gain in kinetic energy.
Okay.
Right? So that's the answer, that's the value. Yep. Any comment? Any other question to ask?
No.
Sorry, we don't
Nope.
have much time.
See you in 10 minutes.
Yeah. See you in